Welcome everybody. My name is Paula Ludwig. I am the event coordinator for the Atlantic Institute, or I should say one of the event coordinators. Welcome to our cultural creations class on 3D printing. Christina is going to be our instructor. But I'm going to play a video about what the Atlantic Institute is about, and hopefully it'll play this time. It's about 3 minutes long is all. And then I'll come back. All right, share screen.
The Atlantic Institute is a nonprofit organization dedicated to promoting harmonious coexistence between peoples of various cultures, faiths, and backgrounds. We seek this goal through peaceful dialogue, education initiatives, and community organization. Our dialogue events bring together experts, community and faith leaders, and knowledge seekers to address social issues that affect us all. We feel dialogue is the most important element in peaceful coexistence, so we try and maintain several panel discussions, TED Talk events, and book clubs throughout the year. These events touch on social issues, race relations, and cultural understanding, and are a mainstay of our programming. The Atlantic Institute's education events are extremely important to our mission of understanding. We want to promote socially forward critical thinking to students of all ages. To that end, we have developed programs that seek to grow the creative spirit of students and help them think about their communities and the world around them. Our Future Leaders of Dialogue event brings together nominated elite students to learn from each other as well as political and business leaders. Our art and essay contest gives students a theme about important societal issues and allows them to create wonderful works of art and writing while steering their minds towards improving their world. We're always seeking ways to educate youth and adults in order to make a peaceful world for all of us. Our community events are designed to transform neighbors into friends and groups of people into a community. By associating with other nonprofits or by our own initiative, we are always trying to discover new avenues to improve our neighborhoods, places of worship, and community centers. We host cooking demonstrations of food from other cultures, work with various nonprofits to help elevate the work of others, and try to find a way to make the lives of those who are disenfranchised or marginalized better. Building a more peaceful world starts in our backyards, so we are dedicated to improving our communities and associations. The Atlantic Institute is always seeking like-minded volunteers and collaborators. If you would like to learn more, find volunteer opportunities, or just want to chat with our staff, please visit our website at www.atlanticinstitutesc.org. or follow us on Facebook. We will never run out of fun, educational, peaceful events. So come, join us to help make this world a better place full of understanding and unity.
Yay. All right. Stop sharing. All right. I'll also put the website out here on our in the chat. If anybody wants the address later, you can then copy and paste it. As it said, we promote all sorts of things. We have all other cultural creations classes.
Going here, we're just trying to figure out where can see me.
We ask that while we're doing this program that you mute yourself if possible. And if you have questions, unmute or put in chat.
When asked about what month I wanted to do this, I immediately picked
Uh-oh.
short start day.
I know what's going on. Sorry. Sorry about that. I thought somebody was talking. It was another program was going on. I apologize, everybody. All right, so I'm going to turn this over to Christina now, and she is going to explain 3D printing to us.
Alrighty, hi y'all. So my name is Chrissy Matthews. I am a senior here at Clemson University. We are actually on Clemson University campus right now in my makerspace, and I'm here to kind of teach you guys the basics of 3D printing and kind of where it's going in the next couple of years. Now, I know this is going to be kind of like a more technical side lecture, so feel free to like stop me and ask me to explain like a term if you have any more questions, but I feel like I can do a pretty good job kind of bringing it to our level and explaining it for everyone, because 3D printing is not the future anymore, it's the present. And that's really what I kind of want to show you guys today. So without further ado, let's go ahead and get started. So I kind of want to talk about three main types of 3D printing. Now, I think you guys may not have known this, but there's actually multiple ways of 3D printing. 3D printing is kind of under the bigger head of making called additive manufacturing. Additive manufacturing is where we make something practically out of nothing, or we add stuff to an object to make it. So if you hear additive manufacturing, you can think like 3D printing or sculpting or I guess another printing and all kinds of other things where you add a material to an object to make something that wasn't previously there. So the first type of 3D printing that I want to get to today is the most common type, and this is called FDM printing. FDM printing is essentially a giant hot glue gun, if you will, for 3D printing. So I'm going to go ahead and show you my lovely 3D printer here. So FDM printing is actually really relatively cheap and is kind of making a big ripple in the United States and probably across the world on popularity. It's probably the next, like the biggest growing technology. It's super cheap and affordable in the previous years. So we have tons of them. I know plenty of kids that have actually grown up in school and they have them in elementary schools now. So let's go ahead and get started and explain what FDM printing really kind of looks like. So this is one small FDM printer. We call these our minis. We have currently 17 FDM printers on our campus. Where can you get something 3D printed? You can get something 3D printed at any makerspace in the area. If you like look up 3D printing makerspace, there are actually a bunch, at least in the United States and South Carolina, a bunch in your area. You can go there and ask them to 3D print something for you. For Clemson students, we offer the service for free because college is a great place of experimenting and learning. And so we offer this service for free for them to prototype and build whatever they want. So to start off 3D printing with FDM, we have what's called filament. We get these spools of plastic. They just kind of look like long spaghetti noodles, I guess. And we get about 1,000 gram rolls. And we use these to make the plastic pieces. So what will happen with the FDM printer is the filament, and I have a little small piece right here for you guys to see, goes into our head right here. So I can lower this a little bit. All right. So our head, where it'll get superheated and spit out the bottom and put on this bed plate. Now I know that may seem like kind of like magic. It really isn't. What kind of happens with 3D printers is we have a plate that moves forward and backwards and a nozzle that moves up and down and left and right. By hitting all of these three axes, we can make something that is a 3D object instead of just on one plane. As the printer will go along, it'll print one layer at a time and build up to build awesome objects like this vase, which you can see is actually really super detailed. This is for your plants. It actually has a lot of little holes at the bottom so the water can come out. We can print fun little characters of super high detail. This is my Mr. Groot from Marvel. And a lot of nursing programs actually use it to model hearts and other organs for prototyping that they can send off to other labs so that they can make an appropriate sized organ and other things of that nature. I use it a lot as an architecture student here at Clemson to model column types or building spaces or making any kind of model that you'd ever think of on a smaller scale. It's really cheap. So one of these printers probably goes for about think this one goes for about $500, but they go as low as about $150. A spool of filament goes for about $20 a spool, and that's 1,000 grams of printing material. So that is like super cheap and affordable. You buy TVs that are more expensive than a 3D printer. The only problem is if you get really addicted and you like to just print all the time, you will go through a lot of filament like we do here at Clemson. So to kind of break down the head a little bit further, the object does not have to be one color. Let's see. The object can be whatever color the filament is. There are dual head extruders that can do multiple colors. Or if you're like me and we have single head extruders, you can just paint over the object at the end. So this is what an extruder head looks like. So essentially, again, the filament will go in the top. It gets heated in this super heated element down at the bottom and gets spit out of this teeny tiny little nozzle to make these long spaghetti-like strands that meld together. You'll see I have fans on either side. That is when the plastic is superheated. As soon as it comes out, it is cooled to a temperature where it is just cool enough to meld, or hot enough to meld to the object, but cool enough that it will harden into a wall of sorts for your object. We also have massive, you can see this, gears, and this helps push the filament through so that's always running on a continuous cycle. To kind of show you how that process works, I'm going to share my screen and show you what a model will look like. Let me do this. Oh, let me do the screen. All right, so this is our modeling system called Cura. Cura takes any object that you can make on a modeling software like SolidWorks or Rhino or AutoCAD, Inventor, and it will turn it into a series of points that the nozzle will follow along the plate so that it can make a 3D object. So this is Mr. Octopus. He is the mascot of the Lulzbot printer. I think he's kind of cute. So what kind of happens here is we'll go do a layer view here. So as you can see, it builds up layer by layer. This is the first layer that will get put down. And you can see where the nozzle is kind of going. If I do show travels, these little blue lines is exactly where the printer head, this big nozzle thing, will go on the printer plate and put down a thin line of plastic. And if we go up, you can see how he starts to build up into an object. So let me see if I can get him turned on his side. No, wrong way. Sorry, all my mouse is being complicated today. Goodness. Come on, buddy. There we go. So yeah, you can see how it starts to build up. The inside, as you can kind of see, is a little bit hollow. That is because I have my printer settings changed over here on the side. So we don't always print objects that are completely full of plastic because that's a little wasteful. And the plastic itself with these structures on the inside is actually really, really tough to break. This thing is probably about 10% infill, but I could probably put this whole table on top of it and it would still stay pretty strong. The plastic that we use anyways is at least very strong, and you can buy very, very strong filament for the 3D printers, but it has to be melted at a higher temperature. But yeah, so these are my settings here on the side. We have a generate support setting. Oh, my lights went off. They'll turn back on in a minute. And a brim, skirt, or raft setting. So these settings kind of help our objects get melded to the build plate. When we're doing hot printing, you know, and the plastic can cool a little too hot or a little too fast and it won't meld quite right. So we do things called a brim, which kind of creates a little pepperoni slice around our object so that it won't peel up on the plate. Generate support creates these little tiny supports, kind of like you would see like scaffolding on a building when they're building a building. It's essentially the same thing. It holds up just little bits of the piece as it moves along, especially if you have big overhang parts. So as you can see, the little hand of this Octopus object, he's got a little bit of overhang area. So I could turn on support and it would build up on something so that the hand doesn't turn into a bunch of spaghetti little strings. So with that, I'm actually going to go start a print for you on my other screen. You can follow me over there. Let me stop sharing. Let's see. Yes, I can tell you about that, but let me finish everything first and we can go through that phase.
All right, so now I'm over here. Oop, there we go. All right, so now I'm back over here. Cool. So to kind of get started with this, I created that Cura file. It turned it into G code, so we know that where our head is going on the 3D printer, so it can start and kind of build up and along. So I'm going to go ahead on my printer settings. It'll have a bunch of options for me, but I'm going to go ahead and do print, and I have my file, and it's kind of going to go through a homing cycle, which is where the head tries to learn where it is on the build plate. So every time a machine goes back to normal, it will come heat itself up and it will home on these little pieces down here. There's just sensors to see exactly where the head is to make sure the builds are lining up on the plate. If they are not lining up, you'll get plastic that comes over the sides, or it won't adhere right to the plate, or it'll start too far up and nothing will happen for your project. So that's going to go through a whole cycle. Let's see. I'm going to leave this guy here, and then I'm going to show you some more examples of what this guy can do.
All right. That should be good. You can watch that guy kind of go through like the homing cycle, and I'm going to sit here and talk through it so I can see what I'm doing. So as you see, it'll hit that back wiping pad, and that's actually going to clean the nozzle. The nozzle I had earlier, I don't know if you've noticed, it is super, super, super gunky. I have a ton of plastic that's been built up on it. That is because 3D printing is often a little messy. We use our printers all year long. We print about 7,000 prints in a year, which is a lot more than what any other, normal printer would use at home. So if you have a personal printer, I wouldn't worry about the technical stuff as much, but we go through a lot. So we have to kind of know these printers inside and out. You can see it's trying to find its way home. It's kind of having some problems. Sometimes our printers do happen. Do happen to lose their way. So it's going to keep wiping the nozzle clean and keep trying to home itself on those back two sensor pads. Hopefully it works. If not, we'll switch over to one of our other 3D printers. Should be good. That one worked. So yeah, as you see, it'll touch all four corners so it can find out where the plate is. And then it'll superheat the plastic. You can see the plastic filament coming into the top, and you may be able to hear it clicking in the background. That's what all these little, I call them alien noises, are here in this space. Looks like it worked. So now it's going to go into a heating phase where it heats up our PLA verbatim plastic to about 200 degrees. So we use PLA verbatim because it is very environmentally safe. It just decomposes well. And we're actually looking into a cycle of recycling filament. So you can buy a filament recycler material or equipment where you'll throw in your old filament or bad parts, and it will turn it into a new spool of filament for you to use so that it'll be completely you don't make an object, you can turn it right back around into like a spool of filament. That is awesome for us because we go through so many rolls of filament a year. I think we buy close to, I want to say 1,000 rolls of filament at $20 each. It may be more than that. But that's just because we are open for all of our students here at Clemson. So as you can see, it's putting down that first layer. You probably won't see much until it gets into about layer 10 or so. This is a relatively quick print. It'll take about 30 minutes. But you can see a little bit of what's going on right now. So while that, yes, there is a little wiper. Let me see if I have an example. So in the back of every build plate, there's one of these things that has a sponge in it. This sponge will, the head will hit down into the sponge and wipe it clean at a certain temperature. And every printer does this. Every printer has their little cleaning sequence. Ours just happens to be on the back of those printers. And like I said, this is a really cheap and affordable printer. Everyone, a lot of schools, a lot of colleges have tons of these printers for everyone to use because they are so cheap. And it's a great way of prototyping. I mean, we have tons of students that come in and they're making examples of like wings of fuselage for planes or Petri dishes or things that you wouldn't normally have or you'd have to go to a machine shop to make. You can come in here and prototype and see how it would work for free here at Clemson as a student or a faculty or staff. The other type of FDM printing are 3D pens, and these are even more affordable and more cheaper. And I absolutely love these things. So the same way, it is a glorified hot glue gun. The filament goes in the top and it comes out in a lovely little string at the bottom, and you can draw or make anything that you can think of. I use these for my architecture school classes. I use them to make little box models that I can build on it themselves. It's a really great, I think these run for about $40 on Amazon. And the filament is maybe about another 20 for like a ton of filament for these things. So it's a really great way of just kind of introducing yourself to the making of 3D printing. Another great use for these is when these printers inevitably mess up and we have prints that come out bad, we can go in and fill in the gaps with these pens. So I really love these things. They're great for like crafting. There's a lot of videos on how you make stuff out there. There are mats that you can use if you're worried about you can't draw a straight line. There are little mats that you just follow along and trace everything out and just glue the corners together with your 3D pen. Like I said, kind of a glorified hot glue gun is basically what FDM printing is. So on to the next type of printing, we actually have SLA printing, which is called stereolithography printing. That is a mouthful. I will just call it SLA because I am terrible at pronouncing it. So SLA printing doesn't use plastic. It uses a poly liquid solution with a laser that hits it to harden into an object. So in essence, I will go show you ours in a minute. They are in another room because they are a little bit more hazardous and a lot more expensive. So you'll have a bed of this polymer liquid plastic, and you'll have a plate, kind of like our bed plates on this thing, and it will lower into the poly liquid, and a laser will shoot up from the bottom and hit it in certain points, and it will harden into an object. And then the plate will move up a little bit, and it'll hit again onto the polypolymer, and it'll harden, and it keeps going like that and actually builds upside down. So while these print right side up, every object that you will do in an SLA printer will print upside down. You can actually still buy these as the general public. They are about $2,000 to $5,000 though for just a little one. And the liquid solution is another, I think it's $500 for a little tank of solution, but you get multiple prints out of it. There's also a lot more equipment that has to go into it. You have to buy a cleaner. The polymer is hazardous, so you cannot use it and can't get it on your hands, you can't get it on you, so you have to actually clean your parts scraping off of gloves. You have to put it in solution, have it cured, and then you actually have to put it into a special oven after that to make sure it's completely hardened and everything is completely cleaned off of it. That altogether probably adds to about $8,000 with all that equipment. So while it is for the public and you can go buy one right now on a Formlabs website, it is expensive. And it is dangerous. You have to find ways of tossing away your extra liquid polymer material. It is not easy to dispose of. You can't just throw it out. It is very dangerous for the environment. And so we have a couple of these at Clemson because we have ways of disposing it through research safety and the people that we worked with. But for the general public, it would be a little bit of a hassle, and the safety, features and the expense, it makes it a lot less popular compared to our FDM printers. However, there's always a however, it prints at a much, much higher quality. So our regular printers that you can see here, you can kind of see the layers. You look really closely, you can see each and every layer. An SLA printer, there are no layers. It is a smooth, continuous piece. It is amazing the quality you get out of these things. This is a sample of somebody's jaw that we got from the upstate. You can buy these online. These are not real teeth, by the way. These are also made in the SLA printer. Just so you know. But you can just see the high detail, and even the words on our piece are just so much better quality than you can get at a regular FDM printer. And that makes it a lot more popular for the university level and high research institutions, or even Bosch, Anderson, a bunch of companies. They love to use SLA printers because their prototypes that they get are not only tougher, but they're way more precise. You won't get problems with feeding or layer shifts. You'll just get a really nice solid piece. The maintenance for these things are a lot more though. It is a lot harder for us as students here at Clemson to maintain these printers because they are so precise. There are 3 tiny mirrors and 1 massive mirror in those FDM printers to direct the beam around. If you get even a speck of dust on those things, the whole printer will stop working because the lasers are just so focused. So if you want to go see them, I'm going to switch back over to my camera while this guy's printing, and I'm going to go show you those printers in the other room. Let me do this. Turn the camera around. Aha, okay. So just to kind of give you a general sense, these are all of our FDM printers. They are safe for the general public to use. So we have them out here in the open and safe, like all students, Clemson faculty and staff can come in here and use them and print on them. The more expensive printers and dangerous printers are in this next room. This is what we call Tim's room. Tim is our research head guru. He makes all these massive, amazing prints. So I'll show you Tim's treasure table of prints. You can see there are just so many on here. And these are not all with SLA printers. Most of these are done with fusion printers, which I will get to in a second. This is our FDM printer. So our FDM printer, as you can see, let me open this up carefully. Alrighty. So as you can see here, we have this bed right here that will lower down into the polymer printer, and a laser will hit up from the bottom. As you can see, I have a little teeny part on there right now, and it's still trying to cure. So we're gonna go back and close this before it freaks out. That part will be scraped off that bed plate and put into our
wash here, which is mostly isopropyl alcohol, and then put into an oven here. We'll have to bake for, I think it's about a day to completely cure. Some other cool printers in this room, which I'll get to in a second, are this massive fusion printer here, and some more in the back there. So these fusion printers are not accessible to the public. You have to get, I think you have to get a bunch of research safety permissions to even have one because of the waste hazard. But the quality of prints is so much better, and I will get to that in a second. So go back. Put you back on Mr. Octopus. Actually, y'all can get a better view. He's maybe about 12, 13 layers up, as you can see. You can see our bed moving back and forth and the head just moving side to side to get those curved area pieces. Let's do this again. All right. Perfect.
All right. So like I said, SLA printers, they are open for the general public, but they are more expensive. As you can see, it is a lot more intense technology and cleaning capabilities that are needed for those printers. Fusion printers are the third type of printer that we will talk about today. They are insanely expensive if you're allowed to buy one. The makerspace has been looking into getting some here, but we just don't have the room for all the safety equipment. Fusion printers use a bed of fine dust, I would call it, and a laser to hit that fine dust and harden it, kind of like an SLA printer would with the liquid polymer. But that dust is super, super, super fine. And that's why you have those massive machines to make sure that it's complete, like vacuum space, you know, nothing goes flying around. But the capabilities with this thing are insane, and they print in color. So this was a scan of one of our students that we did with a 3D scanner, and this was printed on a Fusion printer, and just look at the detail. So much more. It was printed in color. None of this was painted. This is done by a Fusion printer, and just, this blows me away. Another thing that you can do with a Fusion printer, get this little thing. So this is like a grid of squares. And it's super fine. You can see the size of my fingers compared to this. And it was all done in our Fusion printer, color added as well to that print. It's just insane what these things can do. And of course, I love playing with this stuff. This is some chainmail that is printed. It is printed with such a high tolerance that all these pieces came out movable and flexible right out of the printer. So that is just some insane technology, and that's where 3D printing is going. They will be making this technology in the next, I would say, maybe 10, 20 years. Smaller, more compact, more safety friendly, and that's where we're headed, you know, to making stuff like this out of your home. You know, we started with these things. These are already available, and I cannot wait to see where it's going with those Fusion printers. They are just so cool. The only problem is right now, those printers require an extra room of safety ventilation and some other equipment that is really, really dangerous if you're not very careful. You can't be wearing like metal. Things can go horribly wrong if you mix in the wrong chemicals. These things are insane right now. But we will be getting to the point where they won't be so insane. Just like those SLA printers. Just 10 years ago, you could not buy an SLA printer to hold in your house. The chemical properties, the problems, the safety hazards were just too great. But now, you know, we have SLA printers. You can go out and buy an SLA printer. You just have to be very careful. But they're getting safer every year. They're making it so that the polymer is not so toxic that you will be able to use a different type of polymer that won't be so bad to throw away. You'll be able to reuse it. You'll be able to fix it a lot easier as they're making technology advances. And this is happening everywhere. So I'm just super, super excited about where this can go with 3D printing. And yeah, I think that's it. Anybody have any questions? So our FDM printers are currently using, I think combined with all 17 here, I think it's about 20 amps. I'm not quite sure about the voltage. It is expensive, or not expensive. It is a lot, but it's not too terribly much. So if you have like one printer at home, it's not going to blow your circuit. Once it gets going, it doesn't do more than just heat up the element and just keep running. So it's not like it's drawing like a ton of power. I can't say the same thing for an SLA printer since they do use high lasers, but I'm not exactly sure what that number is. And I think, Josie, you had a question about how that house was made in New York. So that is an awesome question. And those are awesome machines. So essentially a 3D printed house is an FDM printer on a just much larger scale. So instead of being hooked, let me kind of see if I can just diagram this out. Instead of being based here, it's not on wheels. Those houses, those 3D printed houses will have a machine that kind of is this U shape. It will have a nozzle that is filled with mortar or cement. And the machine, instead of a bed moving or the nozzle moving, the machine will actually just move around the site. And then as it increases, as we build up, the machine will extend up and 3D print around on the site. So that's pretty cool. Clemson actually has a smaller model of one of those. We have a pottery printer. It's not on wheels. It has a massive bed table that's probably as big as this table that I'm on. But it'll have like a big cone of pottery clay, and it'll just get pushed out the nozzle, and it'll go around and build up into a big, beautiful vase. They're really, really cool machines. Those are a lot more finicky just because when plastic comes out, it is really easy to instantly cool it and melt it. When you're working with something like cement or clay or mortar, it is a lot more messy, and it doesn't like harden as much. So they're still kind of trying to figure out the perfect settings of like not heat necessarily. It's the perfect mixture of water and cement or clay, just to make sure that it hardens when it comes out, but it doesn't come out too clumpy or weird looking. It's kind of fascinating. I'm not a chemist. I have no idea what that mixture exactly is, but it is insane. I hope that kind of answers your question.
Somebody else asked.
I know, it's insane.
Yeah, somebody else asked, how do you get a pattern for the object?
Pardon?
Somebody else asked, how do you get a pattern for the object?
A pattern for the object. So you can either make the object on SolidWorks or any other like modeling software. So let me see how to explain this. As an architecture student, I use a software called Rhino. Rhino is basically you make a bunch of little blocks and you kind of all meld them together, and that's how you get an object, and that object is converted to an STL file. Or if you're like a lot of my friends, they will just go pull their objects off of Thingiverse. I'll actually show you what Thingiverse is right now. So Thingiverse is an awesome website. Oop, let me do this. not going to cooperate with me today. All right, so this is Thingiverse. Thingiverse has almost any file you can ever possibly imagine. Let's go to real quick if it allows me. So there is a community of makers out there in the entire world, and they are always uploading the parts that they're making for their lives up to this website called Thingiverse, and you can download all this stuff for free. So there are gadgets and clocks and gizmos and 3D printed parts that we use for our printers, so we can keep fixing our printers ourselves. You know, decoration, art, all this stuff can be found on Thingiverse, and it's free. And there's a ton of options of where you can go. So if you want to model animals, you know, there's tons of stuff out here for you to use. I love my little slug partner. He is on my keychain. But it is all out here for free, and this is just the popular stuff. We can go to art. You know, you can put all kinds of funny stuff on your walls if you wanted. And this is all 3D printed files. So what you would do is, if I wanted to print this guy, you'd come here, you'd probably take a look at the file. That's what it's going to look like on the printer bed. And you will just download the file as an STL and then upload it to Cura. Cura will turn it into a set of coordinates for the printer to follow, and you send it to a printer, and you're on your way. So it's pretty cool. And it's really,
is Cura free, or is that
Yes.
something you have to buy? Oh, it's free too?
yes, Cura is free. And Cura doesn't work with every printer. So every printer that you'll get, there will be kind of like a set of instructions of like, okay, you need this converter for this printer. We use Cura because they work really well with Lulzbot, our printers, but it kind of just changes. There's like, I think there's like 3D Maker, all kinds of stuff, and it's all free, usually out there. Or even if you couldn't find something that was free that worked with your printer, you can still go and configure your own printer up in Cura so that it'll still work the same way. So it might take a little bit of work and a lot of time, but it is possible. All right, let's see.
How is the octopus coming?
Ooh. Looks like he's almost done.
Ooh.
What
Somebody
about
asked, what about weight?
So as you can see, my little octopus here that we're printing is going to be about 5-ish grams. That can change depending on the density that I want for this print. They usually aren't very heavy though, but it just depends on what you want. So let's see, if I change the density to, let's say 100%. That'll up the ante to about 11 grams. So that'll be 11 grams off of my 1,000 gram filament roll. The bigger the print, you know, the more heavy it's going to be, but it's plastic, so it's generally pretty light. Same with the SLA printers. Even with 100% infill with these things, they're still pretty relatively light. It's not a backbreaker or anything. The printers themselves, this guy's pretty hefty just because we buy the heaviest, dutiest printers for our students, since we're printing about 7,000 prints a year. But the ones that you can buy on like a lower end, like $150, it's maybe, I don't know, 20, 30 pounds at most. You definitely just keep it on like an open table somewhere, so you're not, you know, hauling it from place to place. But it's not something we usually have to worry about.
Was it done?
Oh, yeah, it is. So it's going to cool so that the last layer of plastic can cool off a little bit, and that so I don't burn my hand when I go take it off the printer bed.
So can everybody, we kind of keep track of where everybody's from. So if you could put your city and state, or if you're out of country, because it's being done in the United States, you can put your city and country. That would be awesome. Just put it into the comments. Do you want to go over there, Chrissy, and kind of just show us the done product? You don't have to take him off. I know you said you got a lot of pull, but so we can see him. Yeah.
This is Mr. Octopus. You can see he's still a little stringy just because he's a little hot, but turned out pretty okay. How cool is that?
That is awesome.
Yeah, and like I think someone asked again, where can you go do this stuff? I'm not sure how many places will let you get the hands-on opportunity to touch these printers and use them for yourselves, but there are plenty of places around where you can request a print, and probably even a tour so you can go, up personal and see these printers for yourself. Again, they are super cool just to see and kind of watch. If you're ever on Clemson campus, if you're around, be sure to stop by. We have a big glass wall over here to the side. So you can come watch our 3D printing stuff for as long as you like. So if you're ever around, be sure to stop by. Any other questions? You're welcome. I hope this guys interest you, and maybe maybe you want to go buy a 3D printer now. Start your own creativity somewhere somehow.
Are there any more questions? All right. I want to thank everybody for coming. Check out our website or Eventbrite. We have a lot more classes that we're offering. We do them once a month. I did put our website address in the chat if you want to go looking for it, and you can see. We also do another program called Cuisine of Different Cultures. So you can check out the different food we're doing. We're actually doing February's next Saturday at 11:30, and it's going to be a French quiche. And you can check out that as well. We also have, if you do your own craft and you'd like to demo one for us, I have a couple of months open, and we also have a couple of months open for the Cuisine of Different Cultures. We're still looking for instructors for a couple of months. So I will put my email address in here as well. If you're interested, you can email me. And I really appreciate everybody coming. And if you have any more questions, you can email me. And if I can't answer them, I will pass them on to Christy, who can. Thank you, everybody, and have a great day.
Bye.